Okay, so example 4 starts off by saying that I represents the unit vector due east and j represents the unit vector due north. It tells you that the particle begins at rest at the origin, is acted on by 3 forces, and then asks you to find the resultant force. So anytime we're finding resulting force, we're just adding them together and seeing what the cumulative effect is. So we do 2 plus 1, 3 minus 2, plus minus 1 plus 4, and we add them together and we get on the top line 5 minus 1 is 4, and on the bottom line 1 minus 2 plus 4 is 3. And then it asks it for the form in pi plus qj, so I just change it back to that other notation. Okay, that's part A. For part B, it asks for the magnitude and bearing of the resultant force. So we start off by just drawing a little sketch to help us think about it. So 4i is 4 to the right and 3j is going to be 3 up. So if we come across 4 and then up 3, get a little right angle there, and we just draw a straight line there, and this pink line that I've drawn will be the magnitude, right? So of any bearing, and this is of any vector, right, and this is the same in all the vector work we did. If you want to get the magnitude, we're looking for the straight distance as opposed to the I and the j component form of the vector. So to do that, it's always the same. Anytime we're doing magnitude, we're going to use Pythagoras. So it's going to be the square root of 3 squared plus 4 squared, which is, of course, equal to 5. Okay, that's the magnitude of the resultant force. Now, to find the vector, to find the bearing, we're going to draw our north line in and we measure the angle from the north line to the pink line, our pink vector. And actually, what we see is that it's easy to start by getting this angle inside the triangle. So the angle inside the triangle can be got by doing tan inverse of 3 over 4, right? It's a right angle triangle, so we've got the opposite and the adjacent. So if I do the tan inverse of those, that will give me this angle here, which is, let's check on my calculator, 36.9 to 2 significant figures. So theta, which is our bearing, the blue angle that we're trying to find, well, between north line and the I component, we're going to have 90 degrees. So 90 minus 36.9, right, it's going to be equal to 53.1. Okay, now we're almost there for full marks, but there's one thing that I've missed, which is that we need to put a 0 in front, right? You've only got 2 digits, it's a bearing, 2 digits before a decimal point is not acceptable, it's a 3-digit bearing, so we have to pop the 0 at the front. Finally, part C asks us for a description of the motion of the particle, and all that means is that we are going to think about what's going to happen. Well, the force is acting in that direction, it's acting on a bearing of 53.1, so that means that the particle is going to move, it's going to do more than that, it's going to accelerate in the direction of the resultant force. Okay, and this is the bearing 53.1. So yes, it will move certainly in that direction because it starts at rest, it tells you that in the question, but more than that, it will accelerate in that direction along that pink line in that direction because that is the resultant force. Okay, that's it for the first lesson. So all we're going to do then is have a little go at some questions. So it's exercise 10b. I don't want you to do all of them, there's a lot very similar there, but I want you to do 1ac, question 2a, and then question 3, 5a, 7, 8, 9 and 10. Okay, the questions I'd like you to do from this exercise.